Hello all. So today we will learn problems related to time and work. First we will see different formulas of time and work, and we will see application of those formulas in solving numericals of time and work, right? So let us first see that what is the relationship between three variables while solving the problem related to time and work. That is, these three variables are work, time, and efficiency. So let us define these variables one by one. So work means the total amount of task to be completed in a given amount of time, right? So if suppose I'm supposed to complete a whole work in 5 days. Okay, so in 5 days, I need to complete this whole amount of work, and that will be considered as total work, right? Same the duration, as I mentioned, that I need to complete it in 5 days. So that is the duration of the work, and it is called the time. Okay, that how much duration is required to complete the whole work, and whole work is always considered in this kind of problem. Remember one thing, that whole work is always considered as one, a whole number one, right? And when we will find out that how much work is completed in 1 day, 2 day, it will be a fraction of that whole work, one, right? Now coming to most important variable, which is efficiency. So efficiency of a person or efficiency of a machine is to be calculated, and while calculating efficiency, it says that the rate at which the work is done, and normally it is represented as work done per unit. Per unit can be, the unit can be days, the unit can be hours, or the unit can be week or month, right? So how much, suppose as I have given the example that I need to complete a whole work in 5 days. So how much I will complete in 1 day, that will be my efficiency rate. So what is the portion of the whole work that will be completed by me in 1 day, that will be considered as my efficiency rate. So what is the relation between work and time? So if a person can complete a work in n days, suppose n can be any number, 10, 20, 15, or 30, right? Then work done in 1 day will be 1 by n. Okay, that is the fraction of the total work. So in 1 day, the person can complete 1 by n. So the reciprocal of the total duration. So in 1 day, it will be the reciprocal of the total duration. That is the fraction of the total work is completed in 1 day. For example, numerical example is, if A can complete a work in 10 days, then in 1 day it can complete the reciprocal of the total duration, that is 1 by 10 of the whole work. Okay, so that is how uh, the relation between work and time is established. Now coming to the relationship between work and efficiency. So work and efficiency has always inverse relationship. It means that more, if a person needs more time to complete a work, the person is assumed to be less efficient. On the other hand, if a person can complete the same amount of work in lesser number of hours or less time, then that person will be considered as more efficient compared to the previous person. So efficiency and time has an inverse relationship. If more time is required, then efficiency is, that means efficiency is less. And if less time is required to complete the same work, that means efficiency is more. So here it is mentioned that A is twice as efficient as B. So whatever time will be taken by A, B will require more time. Or from other way around, A will take half of the time to complete the same work. The numerical example shows here that if A can complete the work in 10 days, and if A is twice more efficient than A, then B will be requiring 20 days, because B needs double time to complete the work, because B is less efficient. B is half efficient of A. So B needs more time to complete the work. That is the relationship between efficiency and time. So the same method, that how we can calculate the, I mean, here we are just doubling it. while finding out B's efficiency, and in this case we are taking half of B's efficiency while calculating A's time taken. What will be the time taken by A? And this is how work and efficiency connection is relationship is established, right? Now we will move to a completely different type of formula, which is combined work formula. So sometimes it's not only one person completing the work, but in a work, suppose two persons are involved, A and B, and they are working jointly. So how much time they require to complete a work jointly? So we will look at this. So suppose A can complete a work in X days, X can be any number of days, and B in Y days. Then how much they first we have to find out, and our final objective is how, what is the total time will be taken by them, both of them, to complete the work together. That is our final objective that we need to find out. Now, to find out total time taken to complete the work together, we first need to find out the combined work performed by them in one day. So, how much is the combined work performed by them is in one day? It is just the summation of their efficiency rate. That is, if A can complete the work in X days, then A can complete the work. How much A can complete the work in one day? That will be 1 by X. And how much B can complete the work in one day? That is 1 by Y. So summation of how much they can complete their work together in one day is nothing but 1 by X plus 1 by Y. And if you take LCM of X and Y, it will be XY, and the summation will come out as X plus Y by XY. Right? So that will be the combined work that will be completed in one day. Now, when we know that how much they are completing, so this is the portion, so total work is equal to 1, and they are completing this portion, this is the portion of the total work that they are completing in one day. So how much time, total time they need to complete the whole work, and what is the formula for that? And the formula for that is it should be the reciprocal of total time taken should be the reciprocal of the combined work done in one day. So combine 1 day work. So it is actually the reciprocal of how much they are completing in one day. And if you take reciprocal, it will be nothing but you just have to reverse it. So numerator will become denominator, and your denominator will become numerator. So x into y by x plus y. So that is the formula. So if you know that how much they can complete a one, how much they can complete together in one day, you will be able to find out how much total time they will take to complete the whole work, because it is nothing but just the reciprocal of the combined work completed in one day. Okay. Next, we will move another kind of problems where two-person works in alternate days. They are not working together at the same time, but they are working alternatively. So suppose A is working in the first day and B is working on the second day. Then again on the third day A is working, and again on the fourth day B is working. So how much time will be required to complete the whole work? Okay, that is our objective to find out. So in such problem, there are three steps using which you can find out. That is, first, you have to find out the usual individual efficiencies and you have to combine it. So, when you will find out individual efficiencies and you will combine it, you will find out how much work is done in 2 days. In earlier problem, it was the 1 day cycle. Here, you are finding out the 2 day cycle, because one person is working on one day and the second person is working on another day. So in the first 2 days, how much work is to be completed, that you have to find out. So it is just the 2 day cycles, and it will continue until we will reach the whole work to be completed, that is 1. Until we will reach the whole number 1, this 2 day cycle work will continue. So let us see how we can solve this kind of problem using a numerical. So it says that A alone can complete the work in 10 days and B alone can complete the same work in 15 days. So we can calculate the individual efficiencies from here. Now, if they work on alternate days starting with A, so A will be working on first day and B will be working on second day. Then in how many days will the work will be complete? So let us see how we can solve the problem. So we will obviously, the first step is calculating the individual efficiencies and summing them up. So A's individual efficiency is 1 by 10. Since A can work 1 by 10, complete 1 by 10 of the whole work in one day, and B can complete 1 by 15 of the whole work in one day. So these are the combined efficiencies and combined. Just I mentioned that A's one day week work will be 1 by 10 and B's one day work will be 1 by 15. Then work done in 2 days, because they are working on alternate days. So in first day and second day, so combined work in 2 days will be their combined efficiencies, which is 1 by 10 plus 1 by 15. You have to just find out the LCM of 10 and 15 is 30, and this is how you can find out that 1 by 6 is the final fraction of portion of work that is completed in first 2 days. Yes, it should be mentioned that this portion of work is completed in first 2 days. Okay, now this 2 day cycle will continue. So first day A works, second day B works, then again first day A works, then in the second day, fourth day B works. Okay, so this 2 day cycles will continue. And how much 2 day cycle I need, given that in 2 days 1 by 6 fraction of work is completed? How many 2 day cycles are needed to reach 1? So what is the number that I have to multiply with this 1 by 6 so that I will reach 1? Okay, so that will be our answer. So to reach 1 means the work is completed. 1 means that both A and B has finished the work. So our target is to find to reach to 1, and this is the fraction of work which is completed in 2 days. So if I multiply 6 with it, okay, it's very easily it can be seen from here. If I multiply 6 with it, we will find we will since total work is equal to 1, so if I multiply 6 into 1 by 6, that is this how much work is completed in 2 days, we will reach 1. So 6 2 day cycles are required. So 2 days 6 times, that means 2 days 6 times, and that's why 2 into 6 12 days will be required to complete this work. Right, so 6 2 day cycles are required, and that's why 2 into but you have to convert it in number of days, right? So 2 into 6 equal to 12. So 12, the entire work will be completed in exactly 12 days. This is how we can solve this kind of alternate work problem, right? Next, an application of this time and work, very popular application of this time and work is pipe and cistern problem. So there is one cistern that is to be filled, and there are pipes. Some pipes are filling the cistern or the tank, or some pipes are emptying the tank. Okay, so the pipes which are filling the tank, we will call them inlet pipes. So that will be considered as positive work, because that pipe is actually filling the tank with water. And the other one, which is emptying the tank, will be called outlet pipes. It is kind of negative work because it is just emptying the tank, okay, by removing water from the tank. So we will find out that if suppose in some case it can be that sometimes any of this pipe is open, or sometimes both of this pipe are open. If both of these pipes are open, then what is the possibility, or when the tank will be filled, or whether the tank will be filled or emptied, right? So that can be find out using this formula. So if a pipe fills a tank in x hours, okay, suppose if a pipe fills a tank in just like the previous formula, so if a pipe fills a tank in X hours, its filling rate, what filling rate means efficiency rate. So its filling rate is 1 by X, and same in case of outlet pipes. If an outlet pipes in empties in Y hours, its efficiency rate or its emptying rate is 1 by Y. Now suppose both the pipes are open, right? Suppose both the pipes are open, one pipe is filling and another pipe is removing the water, emptying the tank. So what will happen? So net work done if both pipes are open will be 1 by X minus 1 by Y. So why minus 1 by Y? Because this outlet pipe is emptying the tank. Okay, so here we will not add it, but we will subtract it, because it is considered as negative work. X, the inlet pipe is doing the positive work, so 1 by X is positive, and 1 by Y is considered negative because it is just emptying the tank. So net work done will be 1 by X, 1 by Y. Now the question is, given this, how do we know that whether the tank will be filled or the tank will be emptied? Right? So is there any way through which we can know that whether the tank will be filled or the tank will be emptied? Yes. So it it depends on the relative strengths of the pipe. Okay, relative efficiency rate of the pipe, right? So if inlet pipe's efficiency rate is higher than outlet pipe's efficiency, then the tank will be filled. Okay. On the other hand, if outlet pipe's efficiency rate, which is 1 by Y, is higher than inlet pipe's efficiency rate, then the tank will never be filled. It will be always emptied if both the pipes are open. So if the result is positive, so if the result of this subtraction is positive, then the tank will be filled. If the result is negative, the tank will be emptied. So it depends on the relative efficiency rate. This 1 by X is the efficiency rate of inlet pipe, and 1 by Y is the efficiency rate of outlet pipe. So it depends on whether this efficiency rate is higher or whether this efficiency rate is higher. So if this result is positive, comes out to be positive, 1 by X is higher than 1 by Y, then the result is positive and the tank will be filled. On the other hand, if 1 by Y is higher than 1 by X, then the result is negative and the tank will be emptied.